So today our goals are to identify continuity and to identify increasing, decreasing, and constant intervals. So we've already talked about domain and range intervals, and now we're going to talk about increasing, decreasing, constant intervals, and something called continuity, which is actually kind of interesting if you ever take a pre-calculus course or an IB course that teaches some of those pre-calculus subjects. So to start off, they asked us to do these warm-up questions on domain and range. I'm going to have you do this first one right now. Put an endpoint and an arrow and see how much of the domain and range you can fill in. And if you finish early, you can try 2. But we can also do 2 together, okay? So please adjust your graphs and then try real quick to do the domain and range on this first one. All right, where does your domain start at? What number? A lot of you told me you couldn't read the numbers, but because you know that the axes are crossing here, what number is this? 0, thank you. Okay, so your domain starts at 0, and it goes all the way to the right to what number? Infinity. Okay, infinity always has parentheses, and what does the 0 get? It gets a square bracket, good. All right, then your range starts at the bottom. What y value does your range start at? Also 0. Good. So the y was also 0. And in the y direction, it's going up, which is also what? Infinity. So we ended up with the same domain and range. In set notation, your x is going to be greater than or equal to what number? 0. And then for the range, just change your x to a y. Y is greater than or equal to 0. All right, so that was a nice one because there was nothing confusing about like the arrows going one direction, positive infinity, and one direction, negative infinity. That one wasn't bad. All right, for this one, the domain, the left arrow is going to what? What's all the way on the left? What kind of infinity?
Negative.
Good. So all the way on the left is negative infinity, and that's where your domain starts. This arrow is going up, but it's also going right towards what? All the way on the right is positive infinity. Good. Okay, your range, it starts at the bottom, and we have an asymptote, right? The asymptote is at what number? It's at 0. So your range starts right after 0, and we don't include the 0 because there's an asymptote there. So that means you'll never touch that line. And then it keeps going up to what? To infinity.
Wait, I have a question.
Yes.
So whenever you see like the dotted lines, wherever that intersects, like is that where the first?
That's where it will start.
Okay.
Of course, it could be upside down, and that's where it would end. But in this case, that's where it starts.
And does the line like actually touch? The line can actually touch.
It doesn't ever touch it. It looks like it. And even Desmos will tell you it's touching it because of a rounding error, but it's not. It never is going to touch that line. It just gets so close to it that Desmos can't decipher that it's not on it.
So do you just see where it intersects with the center of the graph?
Say it again.
Like, is 0 is at the center.
Here? 0, 0?
Then I would basically be showing them.
It doesn't go through 0, 0. It goes through 0, 1.
But we're not. Do I have to lock it?
Yes. X is an element of what? All real numbers. Good. X is an element of all real numbers. Y is greater than what value? 0. All right. The thing about continuous and discontinuous that is helpful is it's exactly what it sounds like. Has no holes or breaks. So, a function that is continuous has no holes or breaks in it. Looking at the graphs below, only one of these functions is continuous. Which one is it? 1, 2, or 3? 3. 3 is the only one that has no holes or breaks. A discontinuous function, it does not continue, okay? It has holes or breaks. Okay? Just telling whether or not a function is continuous or discontinuous is pretty easy. The hint here is that you could draw the graph without lifting up your pencil. So I can draw this graph without lifting up my pencil. It's continuous. For this one, I have to pick up my pencil for the next piece. So I'm going to write discontinuous on this one. And what about 2? Is 2 continuous or discontinuous? Continuous, that's right. Wait, you said discontinuous, right? Discontinuous because you have to pick up your pencil for these steps. This is called a step function. I really don't like step functions. I find them hard to look at, but they exist. All right, so for the following functions, state if they're continuous or discontinuous, and then find the domain and range of the functions. So we've done a lot with domain and range, so we're going to probably go through this quickly because I also want to talk to you about increasing and decreasing intervals on the back. Okay, domain. Starting on the left at negative infinity, and then this piece continues to here. Now, question. Let's look at this real close. Is there any number that we have to leave out between the first branch and the second one? No, you guys see it stops at 1, and this one picks up right after 1, so we don't have to leave anything out. Then we go over here. Do we have to leave anything out between these two pieces? No, so all of the x's are covered from negative infinity until infinity. Okay? You got them all.
X's are covered from negative infinity to positive?
If you look at it, this one covers all the negative infinity x's. Then it continues up to here, 1. And we don't leave anything out because 1 is filled in right here. Then this one is 1 to 2, and 2 is filled in here, and then this one is 2 to infinity. So it covers all of them. For the y values, though, there is a lowest y value. Talk to your group about what's the lowest y value on the whole graph.
Is that the domain?
So we're looking at this one. Oh, you're right. This one is domain. Okay, what's the lowest y value, guys? 0, right? Your range starts at 0. Now, it looks like there's a gap over here, but I'm telling you that we don't have to leave those numbers out. Why do we not have to leave the numbers out from 1 to 2? They're covered over here, right? You see that? We include the y values 1 to 2 over here. So even though you see this gap here, they're included here, and it keeps going all the way up to what? Infinity. Yeah. So this is a tough graph to look at for a domain and range, but we got it together from 0 all the way up to infinity. Okay. For this one, your domain, it starts at 0, and then it goes over to 1, and we don't have to leave out the 1 because it's connected here, and we don't have to leave out the 2 because it's connected here. We don't have to leave out any of these numbers, so it starts at 1, and what is the last x value on the graph? It doesn't have an arrow, so it's not going to go to infinity, but that was a good guess. Can you guys see where it stops? I heard 5. Do you guys see how it stops here at 5? Right here. So 1 to 5. Oh, Lua has a good point. I'm wrong about 1. What should it be? 0, thank you. Okay, 0 to 5. So it helps if I tell you the right thing. And then, one of these gets a square bracket. Does the 0 or does the 5 get a square bracket? The 0 does.
But there is no line going through 0 or...
There's a point right here at 0, so that's why we include it.
But domain is like, that's on the way.
So every point has an x value and a y value. So the x value of that point is 0.
It's the y intercept, like it's like you
Okay. All right, guys. To list the range, we're going to list the single numbers because there are no intervals here. Those flat lines are just at single numbers. So we're going to use set notation. That's a set, a fancy bracket. Folks, I didn't draw that bracket by accident. It's a fancy bracket on purpose, okay? If you have trouble writing it, make a little point like that, and then you make like a little parentheses on top of it. This is a fancy bracket. You use this when you're making sets that are not intervals. So we're just listing numbers because there's no intervals this time. So the first number that's included is a y value of 1. That's the first step. What's the y value on the second step? Yeah. So you guys see how we have a step at 1, a step at 2, a step at 3, 4, and then the last one's 5. Okay?
Can you define intervals?
Interval means all the numbers in between. Okay?
Would that be like in between the first and last?
Yeah, so when we do interval notation, we're saying all the numbers in between these two.
So should I write all the numbers in between the first and last one?
That's good. Okay. All right, the last one for domain and range. Let's take a look. Let's put arrows at the end.
Wait, what does that say? 1, 2, 3, 4, 5.
Yeah, in fancy brackets. Okay, for your domain, what's all the way on the left? It's negative infinity. Good. And then what's all the way on the right? Infinity. My range starts at the bottom at what number? 0. And it goes all the way up to? Okay. Having really good participation across the room. I like that. All right, on the back is increasing, decreasing, and constant intervals. We're going to talk about that. How many of you guys know Mr. Lou Fleming? Any of you know Mr. Lou Fleming? Yeah, he really likes Pierre the ant on the back, so you can go ahead and meet Pierre the ant when you turn the page.
Does Pierre the Ant Mr. Lou Fleming. I think he's like a double last name. Maybe like Pierre was his last name.
Oh, yeah.
Because I would say Fleming would be his last name.
But a lot of them only go from that first dog.
Is his last name a double? It's a double last name, right?
Yeah, he hyphenated it when he got married.
Yeah. That's what I want to double last name. I have too much. I have way too much pride. Like I have extra.
All right. As the domain of the function increases and the y value increases, the function is said to be increasing. Okay, so increasing is going up. As the domain of the function increases but the y value decreases, the function is said to be decreasing. All right, so we're still going to the right, but now we're going down. That is decreasing. If the domain of the function increases and the y value stays exactly the same, so that would be like going straight across, the function is said to be constant. So these increases, decreases, or constants in the function happen at an interval of x. So that means we're always going to use x values. All right, so we know domain uses x, we know range uses y, and when we describe increasing and decreasing intervals, we're always going to use x values. All right. So here is Mr. Lou Fleming's mountain climbing ant Pierre. He only travels from the left to the right. Okay? So here he is. He's traveling down here from the left to the right. So the first question is, where is Pierre decreasing? Is he decreasing in the first part, the second part, or the third part of the graph?
Second.
One person had an answer. Anybody else? The second also? I agree. So he is decreasing on the second part of the graph. You see that right there? He is increasing right here. And then what other part is he increasing on? The third part, you guys see that? He's increasing on the first part, and he's increasing on the third part right there. Now here's a good question. When Pierre is at x equals -3, so that would be right here, is he increasing or decreasing? Is he going up or is he going down? Talk to your group. I want you guys to talk to your group about when he's right there at the very top. Is he increasing or is he decreasing? Okay, so at the turning point we said he's neither increasing nor decreasing. So, we wrote neither right here. All right, so down here, here's my example. I'm going to go right here. Imagine Pierre the ant is walking, and is he increasing or decreasing? And as he starts out, is he increasing or decreasing? He's decreasing. So we have a decreasing interval, and it's going to start on the left at -infinity. And it's going to go here to 0. All right, then after that, he's going to increase. He starts increasing at 0, and he goes to infinity. Why did I use parentheses here on the 0? Do you guys remember? Go ahead.
Would it be because it's like a continuous graph? Or like a...
So it is a continuous graph. You're absolutely right. And if I were writing like the domain, it would just be like -infinity to infinity, right? Do you guys remember that part though where we said that at 0 he's neither increasing nor decreasing? Right? Because he's switching. He's switching from decreasing to increasing. So because he's switching in between them, at a turning point we don't include it. So because the turning points are never included, we're going to always use parentheses for increasing and decreasing. We never use square brackets, okay? Always use parentheses for increasing, decreasing. Okay?
For the increasing, decreasing intervals.
Mm-hmm. Absolutely right. All right, I used a lot of space up, and we have this question here to do next. All right. You're welcome. This function has a lot of pieces to it, so let me ask you this. As Pierre starts out right here, is he increasing or decreasing? He's increasing. Is he still increasing? Is he still increasing? Is he still increasing? How about here? No, that's constant, right? So this is all increasing. So he is increasing from 0 to what number? It's 1 on the y value, right? But we're going to use only x values. So we only use x values, and we always use parentheses, okay? So he's increasing from 0 up to what? 20, good.
Is increasing, no. We're always reading from the x.
X,
right?
yes. You're always reading from the x. You're always reading left to right. All right, next section. Is this part increasing, decreasing, or constant? Constant is right. All right, so Pierre the ant is constant from 20 until what? Is it 30? Yeah, you're right. 30. Do I have a third color? No. Okay. Oh, there it is. All right, and then finally he's doing what here? He's decreasing then that would be 30, is it 30 to 40? Is that what you guys get? My eyes are old, so I'm like trying to look at it. I can look at it better up here. Oh, and then something else happens. What happens last? Increasing again. So let me put decreasing on that piece. And then increasing again. And so what I'm going to do, instead of writing the word increasing again, I'm just going to put a comma here, and then I'm going to put my next interval of increasing. So it's 40 to 50. 40 to 50. And this part is increasing. All right. I'm going to have you guys work on the challenge. And I'm going to give you this little piece of advice. To help you look at the X numbers, I want you to take every point and just do like a little connection to the x-axis, and that helps you focus on the X numbers. Okay? So if you connect the turning points to the x-axis, that will help you. So I want you to identify increasing, decreasing, and constant intervals on this. I want you to work with your group. It was increasing from here to up here. Even though they named that point, we don't have to stop there. So we have an increasing interval from -8 to -2. We have another one here to here from 0 to 2. And then another one here to here from 5 to infinity. If you put a U in between those, that's really great. If you didn't, that's also really great. I don't mind either way. Okay, so -8 to -2, 0 to 2, and 5 to positive infinity, which is over here. Okay, on this side, we start at negative infinity until we get to -8. And then -2 to 0. And then 2 to 5. Remember that we're only using X values the whole time. You never write the Y values for increasing and decreasing.